Welcome to Maths with EJD. This is the fifth video in the integration series under the basic calculus set of videos I've been making. So here we are considering integration of trigonometric functions. Remember, under differentiation, we saw how we could differentiate sine by first principle. Then I give an exercise on how to do that with cosine. And then along the line, when we got to product quotient rule, for instance, we saw how we could differentiate tan x. So where we saw that tan x is sine x over cos x, and then you could integrate that, differentiate that to get sec squared x. So all of that idea is going to be helpful here as we embark on integration of trigonometric functions. And don't forget, at the end of all the videos, I have a comprehensive set of exercise. So you want to see the last video in the integration series to see several questions and formulas that can help like that. So let's talk about integration of trigonometric functions. Integration of simple trigonometric functions is easily understood from the perspective of anti-differentiation. You know, we've seen that integration is the opposite, the reverse of differentiation. For instance, you know that when we differentiate sine x, if you differentiate sine x, you know, you get cos x. That means that if you integrate cos x, you get back sine x. That's exactly what is happening here. So if you integrate cos x, you get sine x, because when we differentiated sine x, we got cos x. In the same vein, you remember that, okay, well, maybe it was an exercise. If you try that out, you discover that when you differentiate cos x, you get minus sine x. That means that when you integrate sine x, the minus moves to the cos and you have minus cos x. That is why integral of sine x dx is minus cos x plus c. So that is the basis for integration of trigonometric functions. See it as anti-differentiation or reverse differentiation. Okay, so let's delve into some more serious things, having this as a background. So differentiate sine x, you get cos x, means integrate cos x, you get sine x. Differentiate cos x, you get minus sine x. That means if you integrate sine x, you get minus cos x, of course, plus the arbitrary constant c. So with that, can we try to integrate tan x dx? Can we evaluate that integral? Of course, we know that integral of tan x dx is the same thing as sine x over cos x. So integral of tan x dx is the same thing as integral of sine x over cos x dx. Now, so first of all, this is looking like the kind of function we treated under derivative function ratio. So you discover that if you have d dx of cos x, that is, if you differentiate cos x, you discover the result is minus sine x. And because it is minus sine x, what you have here is actually close to minus sine x, except that the minus is missing. Again, we'll use that idea of multiplying by 1. Now, you know, 1 can be anything. 1 is a very helpful guy. Whenever you run into problem, just remember 1, that you can break 1 into anything to suit your needs. Okay, so again, because we need minus sine x and we have sine x, so we remember again that, okay, sine x is the same thing as 1 times sine x. We have not done anything wrong if you say 1. And then you also know that 1, since you need minus sine x, that means you need to multiply sine x by minus 1. So you discover that 1 is still minus 1 times minus 1, then times sine x, because minus 1 times minus 1 times sine x is still sine x. Okay, so now that you brought that into it, you can simply go ahead and multiply sine x by minus 1. So you have minus sine x over cos x, and this minus 1 comes outside here. So you have minus here and minus here. And now the deal is done. If you differentiate cos x, you get minus sine x. And then we can use the law of derivative function ratio, that whenever you differentiate the denominator and you get the numerator, the integral of that expression is simply going to be the ln of the numerator. So, and that is really applicable here. So differentiate cos x, you get minus sine x. So, and then that means for this whole expression now, the answer is ln cos x plus c. So, and you have the minus outside, it just comes here. So it means that if you integrate tan x with respect to x, you get minus ln cos x plus c. Very simple logic. Okay, so whenever you run into trouble and you don't get something as perfect as you want, remember 1. Just remember 1, and that you can break 1 into whatever. Okay, so let's do something a bit more technical here. So now we want to evaluate the integral of sine squared x dx. Okay, so we have to use our knowledge of trigonometry since there is no direct solution. So if you look at sine squared x dx, there's no straight way to do this right now. So you have to now remember the idea of integration, trigonometry. Painfully, I've not done any series on trigonometry. I'm going to do that somewhere along the line. Probably that will come after calculus. I'm not sure yet. All right. So, but then we know that from trig, cos 2x is the same thing as cos x plus cos x. And then when you break that down in trig, right, cos 2x is the same thing as cos x minus sine x sine x. I mean, you can get that in your four-figure table. For instance, if you're in high school or if you're in secondary school, you have this kind of thing in your four-figure table that cos 2x is the same thing as cos x minus sine x sine x. And then cos 2x is cos squared x minus sine squared x. Okay. Don't never forget that what you're looking for is the integral of sine squared x dx. So now, since you're looking for sine squared x, you can break cos squared x. You remember, I think we've used this a couple of times, that sine squared x plus cos squared x is equal to 1. So because you need sine squared x, you can break cos squared x into 1 minus sine squared x, of course, minus the original sine squared x that was there. So you open that up, you have 1 minus sine squared x minus sine squared x. So this is minus sine squared x minus sine squared x. That's like you're owing 1 sine squared x and you're owing another sine squared x 1. So that's you're owing minus 2. You're owing 2. That's minus 2 sine squared x. Mind you, if what you wanted to integrate was cos squared x, then you make sine squared x into 1 minus cos squared x, so you can get only cos. All right. But here our focus is on sine. That's why we're doing that. So now we have 1 minus 2 sine squared x. So you can easily make sine squared x the subject of formula, right? Make the whole expression in terms of sine squared x. So, and how to do that? You can move sine squared x here, just 2 sine squared x, you have that here. And then this one that is here is here. Then cos 2x comes over here. So that way we have 2 sine squared x minus cos 2x. And then you can divide through by 2, so you can have just sine squared x alone. So you have 2 sine squared x is equal to 1 minus cos 2x divided by 2. And that means you can have 1 divided by 2 minus 1 over 2 cos 2x. So sine squared x is still the same thing as this. Now, the interesting part is that it is easier to integrate 1 over 2 minus 1 over 2 cos x than to integrate sine squared x, because you can easily integrate 1 over 2. We know whenever you integrate a constant, like integrate any constant, maybe 2 dx, it just takes the x automatically. It just becomes 2x plus c. It just takes the x behind the d. So if you can easily integrate half cos 2x, because now this is just like function of a function, right? To integrate this now. Of course, we'll see that in the next slide. Let me not get ahead of myself. So the next thing is, since you have broken sine squared x down into something simpler that is easily integrable, so we can perform the integration. We say integral of sine squared x dx equals integral is the same thing as the integral of half minus half cos 2x, because sine squared x dx is the same thing as half minus half cos 2x. So of course, so you can break this down. You have the half is constant, so you can bring it out. So you have half dx. How normally it should be integral of half dx. So the half is constant, so it comes out. Then minus, so this minus now, you have it here, half cos 2x. So the half is out, and you have integral of cos 2x dx right under as the integrand, okay? And of course, the next thing we are going to do here is this. I already told you, if you integrate the x, you just get x. So you have half out here multiplying that x, then minus this half now. But then look at this. To integrate cos 2x, normally if it was differentiation you wanted to do, to differentiate cos 2x, you differentiate 2x and you get 2, right? And you now multiply it by when you differentiate cos, you now get minus sine 2x, and that's differentiation. So this is minus 2 sine 2x. But then for integration, right? See what happens. You already know that when you integrate cos, you get sine. But of course, this 2x now, in the case of integration, of course, you have this half out here. So you have half times, so differentiate 2x, you get 2. So you have to divide by that 2. In integration, you divide by the 2 instead of multiplying like the other time. Then when you integrate cos, you get sine, so the sine 2x comes back. Normally, when you differentiate cos, you get minus sine. When you differentiate sine, you get cos. So if you integrate cos, you just get your sine back. So, but because of this 2x now, if you differentiate 2x, you get 2. So you divide by 2 because you're integrating. In the case of differentiation, you multiply by the 2. And that's why you have half times half here. This is half times the sine 2x. That's why you have it here. Okay. This half x was already sorted. So pay attention to that. I'll go over that once again. So you have integral of half dx, this half integral dx, minus half cos 2x dx. So you have half out here, integral of cos 2x dx. All right. So when you integrate dx, you just get x straight up. And then you have this minus still here. And then this half, you have it here. And then to differentiate, integrate cos 2x, right? Differentiate 2x first. When you differentiate 2x, you get 2. For integration, you divide by that. So, and then when you differentiate, integrate cos, you get sine. So you have sine 2x divided by 2. So that divided by 2 is what gave this other half. So you have 1 over 2 times 1 over 2 sine 2x plus c. So you can tidy things up. And then you have half x minus 1 over 4 sine 2x plus c. And that is the final result you end up getting when you integrate sine squared x dx. So you can use the same idea for integral of cos squared x dx. The only thing is that in that place where you change sine squared x, cos squared x to 1 minus sine squared x, you change cos squared x to you change sine squared x to 1 minus where you change cos squared x to 1 minus sine squared x, you change cos squared x to 1 minus. You change sine squared x to 1 minus cos squared x. You figure it out if you follow these steps. All right. Okay, so let's do something a bit more. Another one, like all these things are, requiring the knowledge of trigonometry. So again, of course, never mind. If you have issues with trig, I'm going to take a series on trig after some time. So here we want to evaluate sine of 2x cos x dx. We are still talking about integration of trigonometric functions. So this is sine 2x cos x dx. This doesn't look like something you can easily integrate, but in trigonometry, right? You need to, there are a set of laws. You have sine p plus sine q equals 2 sine p plus q divided by 2 cos p minus q divided by 2, then sine p minus sine q. So you have all these kind of expressions like 4 to 4, 5, 6, 7, 8 like that. At the end of the day, we need sine something and cos something to go together. And you can see we have sine something, cos something, sine something. So we want to use all these four now to get the identities that match with that. Again, if you go through trig, you will understand what I'm about doing. So from inspection, it looks like 4 will do the job. So look at 4 now. This is sine and cos. So this is expression 4. It's doing that job. This is one of the trig identities. So you have sine something and cos something. So because this is sine something and cos something, so this does the job. So how we arrive at this, you will get when we talk about trig again. So now we need, of course, there's no 2 in front of this one. So it means you have to find a way of taking the 2 away. So the 2 has got to come back here. So you're going to have half into sine p plus sine q. And that's what you have in the next slide. Look at it right here. So you see now that so now we just have sine p plus q over 2 cos p minus q over 2 equals half into sine p plus sine q. That's what you have in the next slide. So, okay. So you see sine p plus q over 2 cos p minus q over 2 is the same thing as half into sine p plus sine q. So again, you can break that down into, of course, same thing. That is now half sine p plus half sine q. So comparing the left-hand side, so if you look at the left-hand side now, this is the left-hand side, this is the right-hand side. Comparing the left-hand side with sine 2x cos x. Now, you remember what we wanted to do was to integrate sine 2x cos x dx. So now this looks exactly like sine something cos something. So it means that if we compare this expression and this expression, it means that p plus q over 2 is 2x. That's why you have p plus q over 2 is 2x. And then cos p minus q over 2. So it means p minus q over 2 is the same thing as x. So we have p minus q over 2 equals x. So it's like we have a simultaneous equation now. And of course, on the right-hand side, we need to solve for P and Q. So if you can get P and Q, then we have an expression that can be easily integrable. So it's looking like a very long journey, but just follow through. So now we want to get values for P and Q by solving this simultaneous equation that has emerged in 10 and 11. Of course, the next thing we need to do is to multiply it through by 2, and we get P plus Q. We get P plus Q equals 4x, and we get P minus Q equals 2x. And then we solve for P and Q, as you're going to see in the next slide. All right, so look at it here. So if you solve those two equations simultaneously, right? Okay, if you solve those two, what was that again? Let me see. Let me see if I need to just do that actually. Okay, P plus Q is 4x, P minus Q is 2x. P plus Q, 4x, P minus Q, 2x. So if you solve that simultaneously, you end up getting what we have here. But let me do that. P plus Q is 4x. P minus Q is 2x. So this is a very simple thing to solve because we can just add up and eliminate the Q's. So you have P plus P, that's 2P, equals 4x plus 2x, that's 6x. So you see that P is equal to 3x. And now that P is 3x, you can see P is 3x here, right? Then the other thing, we can just also eliminate, we can just eliminate Q by subtracting. So we say P minus P, that's 0. Q minus minus Q, that's 2Q, equals 4x minus 2x, that is 2x. Divide through by 2, Q is equal to x. And that's why you have this, all right? So now that that is settled, so we now know that P, so you see that sine 2x cos x can be the same thing as half. You remember that the other time sine P plus Q over 2 cos P minus Q over 2 is equal to half sine P plus half sine Q. So that means now sine 2x cos x will just be half sine P, which is 3x, plus half sine Q, which is x. So with that, we take care of that very easily. So remember, it is integration we wanted to do. So we've gone back to the integration. So it's easier to integrate this expression than to integrate this complicated one. So, right? So we have integral of sine 2x cos x dx equals integral of half sine 3x plus half sine x dx. So now we open things up. So you have half sine 3x dx. So half can go out. So you have half sine 3x dx, then half sine x dx. So now we have this. So half is outside, right? So to integrate this, right? To integrate sine x dx, differentiate 3x, you get 3. So divide by that 3. Division by 3 is the same thing as multiplying by 1 over 3. Times, when you differentiate sine, when you integrate sine, when you differentiate cos, you get minus sine. So when you integrate sine, you get minus cos. So with the 3x, so you have minus cos 3x plus this half is out here. Differentiate, if you differentiate cos x, you get minus sine x. So if you integrate sine x, you get minus cos x right here. And then you can tidy these things up and you get your results. That's 1 over 2 times 1 over 3. That's 1 over 6. Of course, there's minus here. So you have minus 1 over 6 cos 3x minus, plus and minus 1 over 2 cos x plus c. So when you integrate this, this is what you get. All right. So that looks somehow, but try your hands on it by yourself. You'll surely see that it's not beyond you. It's something you can surely do. So don't forget, at the end of this whole integration thing, I have a comprehensive list of exercise, some practice questions, to show you, so you can try your hands on them. So with this, we come to the end of integration of trigonometric functions. So make sure you subscribe and press the notification bell so you can always get alerted whenever a new video is released. See you in the next video.